In this video, we are going to look at 7.6, apply the sine and cosine ratio, day 2. So we are going to look a little bit more closer at the relationship between sine and cosine. So I have provided an investigation here with a trigonomic table, and it says to look at the trigonometry table. Notice that every sine value has a matching value for cosine. So the first thing we're going to look is at the color coding that I have provided. So it says sine 5 degrees, which I have here in red. And if you look at the other side of the chart, the 0.872 pops up again right here, except now it is in the cosine column and it is at the 85 degree. So that means that sine 5 degrees is actually the same as cosine 85 degrees. Now let's look at a few more to see if you can notice a pattern. Sine 10 degrees is equal to cosine 80 degrees. Sine 23 degrees, which is 0.39 or 0.3907, matches over here at cosine 67. And then I believe sine blank, and I'm wanting to look at cosine 57. So if I go over here to 57, I see this purple right here. And then if I look over here, cosine 57 matches sine 33 degrees. And the last one here is two identical trig ratios, the 0.7071, and that is 45 degrees. Sine 45 is the same thing as cosine 45 degrees. So now that we've made these observations, do you see what's making these equal? Well, if you look here and here, there's something special about those angles. 10 and 80, 23 and 67, 33 and 57, 45 and 45. So hopefully you notice that these angles add up to 90 degrees. So the angles add to 90 degrees. So we have a word for geometry. That means they are complements of each other. So they are complements. So that means they are complementary. They add up to give you 90 degrees. So what is our conclusion? Now this is sometimes the confusing part for some students, is if I do sine theta, what does that mean about cosine? Well, let's use 5 and 85 as an example. If we know sine theta is 5 degrees, then the cosine has to be the leftover from 90 degrees. So we write it 90 minus theta. So that is how you're going to be writing these. Sometimes it is sine x, so cosine would be 90 minus x. Now, why is the 90 always first? It's because we cannot get a negative degree of that angle. So that leads us to an idea of a cofunction. So what is a cofunction? Okay, well, that is when two trigonomic functions are complements of each other. When two trigonomic functions are complements of each other. Now, it's just kind of like that they're buddies, okay? They're friends. They are complements. So if this right here is sine, this right here is cosine, then they are going to add up and be complements. Now remember, this is only dealing with the acute angles of a triangle. So now let's look and see why this is working in this next little piece. So it says, why does this work? So let's examine this using the 23, 67, 90 right triangle. So it says sine theta would be opposite over hypotenuse and cosine theta would be adjacent over hypotenuse. So in this example, we are going to look at sine 67 degrees. So opposite would be x, and the hypotenuse would be z. Cosine 67 would be adjacent y over the hypotenuse z. Now, moving over to this next one, we are going to look at the 23-degree angle. So cosine 23 degrees is going to be adjacent over hypotenuse, and sine 23 degrees is going to be the opposite over the hypotenuse. Now, this is when you need to make the connection. If you now look across at these, sine 67 is x over z, and cosine 23 is x over z. Therefore, they are equal. The same thing with cosine 67. You can see here the 67 is y over z, and 23 is y over z. So, the big thing to notice is that that 67 and that 23 are complements of each other. They have the same ratio. Same thing with 67 cosine and sine 23. They have the same ratio. So the big picture of this, in a right triangle, so that is very, very important. We must be dealing with a right triangle. The two acute angles, let's say A and B, are always complementary because there's only 180 degrees in the triangle. And these two ratios are comparing the exact same sides of a triangle. So that is the big picture. They're complements. So this is what you need to know before we move on to the problems, is this right here. Now, sometimes it'll use theta, sometimes it'll use x. You've got to know that they are complementary.